The focus of this video is line of symmetry in geometry. If a polygon in a plane can be mapped onto itself by reflection in a line, then the polygon has a line of symmetry. The line of reflection is the line of symmetry. A polygon can have more than one line of symmetry as demonstrated in various polygons below. Count the number of lines being drawn in each of the regular polygon. It is same as the number of sides of the regular polygon. Now we are going to discuss this. First we will use a triangle. So this is the triangle. We would like to find out how many line of symmetry we can have for a equilateral triangle, because we are discussing about the regular polygons. So let us see how many lines of symmetry. As it says, the line of symmetry means if the figure is can be mapped onto itself. So I'm going to see the first line of symmetry of this triangle, which is equilateral. Let us draw this. So this is the line of reflection which I am saying, and it is going to be the line of symmetry. And when I fold this, I can fold this, and it is the polygon is mapped on to itself. So you can fold it and it exactly fits on the half of the polygon. So this is one. So let us do that. So I got one of these by drawing from the vertex to the midpoint of the opposite side, because this is a triangle with 3 sides. Let us try the other one. Let us see what is the next one. Then I'm trying from another vertex, so I can draw this. When I fold it, it maps onto itself, and this is the second line of symmetry. Likewise, I can draw the third one, and it goes, you fold it, and so in an equilateral triangle we saw there are 3 sides, so there are 3 line of symmetry as it is written here. It is the same number as the number of the sides of the polygon. Let us see what happens when we have a square. So in here we can draw the same thing. I'm going to draw, this is the line which is from the midpoints to the midpoint of the opposite side. So this is one. Then I'm going to have another one which is across this line. This is going to be another line of symmetry. So there are 2 so far. Then I have the third one, which you can see is going across by the one of the diagonal. So this is the third one, and I have this is the one is going to be the fourth one. So a square has 4 sides, and we counted 4 of the line of symmetry. But remember, this is all applicable to the polygons which they are regular. Let us see one more, which is pentagon. So the pentagon, the first one you can see is this one. Likewise, it will fold it. So this is one. This is another one, which is the second one, and this is the third one, if we count, and then it is coming, this is the third, then comes the fourth one, which is from this vertex is going across, and the fifth one. So this is the last one, and that is the fifth one. It's coming from here, and that is also the fifth line of symmetry in case of a pentagon. So we saw that. So likewise, when we have a polygon with the odd number of sides, then we draw the line from the vertex to the midpoint of the opposite side. So what happens if I have a figure which has, this is also the 5 pentagon, so we can see, now we are not going to fold it here, but we can count starting from this vertex. This is the 1, then from this vertex goes 2, this one goes 3, this is 4, this is 5. Likewise, if I have 6 sided, so you can count again starting from this vertex, 1, then 2, let me draw the line, you might be able to see the line. So 1 is coming from here to here, then this is the second one, this is the third one, I'm counting from the vertex of each, third one, and then I'm going to count the midpoint. So these are the 3 we counted, then this one, which is 4th, this is 5th, and this is 6th. So we have 6 of the line of symmetries in case of a hexagon. If we continue doing this, let us do when we have 7. So 7, this is a 7-sided, and you can see that you can count this starting from the 1, then 2. We can count from the midpoint, or we can count from here. So we can go 1, this is 2, this is 3, then 4, then 5, then 6, and then 7. All other has already been counted. So if a pentagon is 7-sided, then it will have 7 line of symmetries. But likewise, we can count as many as we can go, like this is octagon, pentagon, 10-sided, and we can really count these number of sides. This is 15-sided, so all these diagonals are going to be counted. There are going to be 15 of them. Let me go back, and I'm trying to make it, let us say it is 5-sided. It's a pentagon. So in the pentagon, we saw there are going to be 5. But this is all regular. What happens if I have a figure which is not regular, like a trapezoid? So the trapezoid will have how many of the line of symmetry? Let me try it. So if I do across this, and if I fold this trapezoid, so half of the trapezoid will sit on top of the other half, exactly it will fit. So that is 1. If I try to do the other way, and if I try to go across the line of symmetry I'm trying to make parallel to the bases, it's not going to work, because you can see it is not mapping on itself. The other part is falling. It is not really, when I'm trying to fold it, it doesn't sit on top of the two vertices. So is this how many line of symmetries a trapezoid has, which has only It is, you can say it is an isosceles trapezoid because the two sides are equal and the two obviously the bases are parallel, so there is only one line of symmetry in this case. In another video we are going to discuss the line of symmetry as well as the rotation symmetry. Both of them will be discussed in another video. I hope you understand the concept and how to find the number of symmetries or line of symmetries in case of a regular polygon.